everyone, welcome to episode 2. Thanks for stopping by. Today we're going to be discussing your computer's processor. We're going to talk about what it does and why it is so important. Many people know that the processor is an important part of your computer. In fact, without your processor, technically you don't have a computer. It is considered the computer's equivalent to a human brain. It's where all the magic happens of reading all the ones and zeros, otherwise known as binary code, or also known as the language of computers. The processor orchestrates what goes on. It converts data input into information output. It is the executioner because it executes commands. Like when you click a button in a game, that input gives the CPU a set of ones and zeros. The CPU then takes that set of ones and zeros, reads it, and then outputs a set of ones and zeros, telling the game what is supposed to happen when you press said button. Alright, time to geek out for just a couple of minutes here. If you want to deep dive into what a processor is and how it works, go ahead and continue along. If you don't feel like you want to watch this whole deep dive, it might be over your head, then go ahead in the description below and click on the little timestamp that I put down there for the TLDR version. The processor is made up of two key parts: the control unit, or CU, and the arithmetic logic unit, or the ALU. The control unit is like a queen bee where it goes and it tells everybody what to do. The arithmetic and logic units are similar to worker bees in the fact that they go out and pollinate and come back with that sweet, sweet nectar to make that honey money. The CU gets the data input and then masterminds how to show the information output. The one thing that the CU has to do is that it has to talk to both the ALU and the memory on your computer. The reason that the control unit needs to talk to your memory is that the data input needs to come from somewhere. The control unit needs to know how to direct everything for each and every single job that it needs to perform. This is similar to reading a recipe or reading instructions for like an IKEA dresser or something that you have to create. All this information is stored within your computer's main memory. The CU takes the instructions and tells the ALU to find, copy, and move the necessary information into the main memory. This memory in your computer is your random access memory, or your RAM. RAM shouldn't be confused with storage. They're two different things. Storage is where information is kept for a long period of time. Everything within your computer that you have saved or installed, like pictures or your documents, those are all stored on your hard drive, whether that be a hard disk drive, SSD, or whatever you're using. The difference in RAM is that once you go and you click on a document that you want to open, that document is taken from your long-term storage, your hard drive, and put into your computer's RAM. But before you can open the document, you have to open the program. The information for how that program works and runs gets taken from your computer's hard drive, and that gets tossed into the RAM as well. Once you click to open your document, you send a data input to your processor's control unit. It takes the input of opening up your document and tells the processor's ALU that it needs to grab your word processor, whether that be Word, Google Docs, Apple Pages, or any of the other numerous word processing units out there. After your ALU goes and grabs all the information and pops it up on your computer screen, it then goes in and grabs the document and makes the document appear within your word processor. Like I said before, everything that it is doing is originally stored within your computer's hard drive and is moved into your computer's RAM. Because of the fact that your RAM is so much faster than your computer's hard drive, and your computer's processor will directly talk to your RAM, and it needs faster access in order to be able to do the calculations that it does every second. So once you go into your Word document and you start typing everything up, anything that you type or any changes that you make is stored on the computer's RAM. Once you go in, you click save or save as and save it as a document onto your hard drive. Then any information that is stored on your RAM gets put back into your long-term storage or your computer's hard drive. This happens by when you give the input to your processor to save it, it goes through, tells the ALU that it needs to take what's on the RAM and it needs to move it back into your storage. Once you close the program, the allocated RAM for it is then completely taken off and any saved information is gone. But most of the time today, there is a little place marker that is kept for just in case, like if your computer's battery dies while you're typing, or if you have a desktop and your power goes out, or if either the word processor or your computer itself crashes. You can still typically go back in, boot everything back up, and you're able to find a saved piece of that document that's typically kept in your RAM. And this all happens because of the fact that Word and many other word processing units have an autosave feature. So they'll go through as changes are made and they'll automatically save, which was a huge blessing for anybody that has ever had their computer crash before and they didn't have any sort of autosave feature, so you had to start completely over from the last point where you saved it at. So many people don't understand the benefit that autosave is unless you've played games where it doesn't have an autosave and you go into like a dungeon or you go into a camp, or like in Skyrim if you fight a dragon before you save it and you end up dying, you have to start back over from your last save point. That can be such a big hassle, and I'm so happy for autosave features for any documents that I had to type up throughout college, because there were plenty of times where I wasn't paying attention to my battery and my computer just died. So autosave feature is just a huge blessing, and you should thank all the developers for continually updating and finding better ways to make their applications work for their consumer, otherwise known as you and me. Registers are another element that help the whole process work faster. Registers aren't part of your memory, but they are a form of memory to help speed up each process. Registers work under the direction of the CU. They perform such actions as transferring instructions or data, as well as accept, hold, and perform arithmetic or logic comparisons, all at high speeds. Registers are a temporary, convenient way to store what is used in transactions. There are 4 types of registers. There is an accumulator. Its job is to go and collect results of any computation performed. Another type is the address register, which keeps a log where each and every piece of data or instruction is stored in the memory. It kind of works like our mailing system where each building or house has a specific address. Same thing with anything that is stored on your computer, it has a specific address within it. So if you go into your File Explorer on your Windows PC, you can click on it and then you can go to this PC, then you can click on your specific C drive, then you can click on user, then you can click on the specific username, and it'll pull up. So everything has a specific place within your computer. And if something is missing or corrupt, most of the time you will get an error popping up whenever you try to open a specific program or a specific file, which really sucks because most of the time you have to start completely over again. So a third type of register is called a storage register. These registers will temporarily hold data that has recently been taken from or is about to be sent to your memory. And then lastly, the fourth kind of registers are general purpose registers, and they can be used for a multitude of different tasks. Your processor is the workhorse of your computer. How fast your computer gets work done is based on 2 different factors. One being your clock speed and the number of cores that your processor has. The speed at which each process is executed is known as your computer's clock speed. Clock speed is typically the more important statistic when it comes to most people. When you go shopping, this is the number that is typically when you look at the processor speed. As of the making of this video, which is 2019, that measurement is in gigahertz. 1 gigahertz is equivalent to 1 billion calculations per cycle. A cycle is just the same thing as saying like within 60 miles per hour. A clock cycle is the amount of time between two pulses on an oscilloscope. A lot was just said, so let's kind of break that down a little bit. An oscilloscope is a device that measures a waveform of an electrical signal. Electricity, like pretty much everything, such as sound, light, microwaves, gamma rays, all of them put out waves that can be measured. In electricity, these waves are called Hertz. Hertz, named after its founder, Heinrich Rudolf Hertz, is 1 cycle per second. And like I said before, computers today are measured in gigahertz. This is 1 billion cycles per second. These electromagnetic waves are sinusoidal waves. As some of us know from trig or calculus or anything, a sine wave. The higher the clock speed or frequency at which the sine wave happens, the more compact and the more jaggy they will look on a graph. And the slower the speed for the clock speed or frequency, the more round the waves become. When processors came out, they were just a single core processor. With single core processors, they're only able to execute one instruction at a time. Today, multi-core processors have become pretty much the norm for just about everything. Nearly every computer, in this case, we're talking desktop computers, laptops, tablets, even cell phones, all have at least 2 cores. This gives computers much more computational power and allows them to do multiple things at one time. And not too long ago, the CPU got another computational boost when simultaneous multi-threading, or SMT. Intel has kind of come up with their own naming. They call it HyperThreading. AMD, they typically just call it SMT. And essentially what this means is that you're taking, like, if you have a 2-core CPU, you're taking those 2 physical cores and then you are creating 4 virtual cores out of that called threads. This virtual doubling of cores allows each core to perform 2 tasks at one time, greatly improving efficiency, and essentially you're doubling your performance. One of the biggest reasons for the advancement in clock speeds as well as core count is because of the content that we consume. You got 8K TVs coming out later this year, you've got 4K content that came out just a few years back. 1080p was probably about a decade ago now. And so this is just rapidly increasing, and it's causing us to need to continue to grow. One of the big pushers are video games. Everybody wants photorealism. I guess not everybody, but I certainly do. I like things that look as beautiful as possible. Computational power within both CPUs as well as GPUs needs to continue to increase in order to help push that along. And you have VR as well that's come out recently, and that pushes things even further. So with more cores, you have the ability to have more things done at one point in time. With your clock speeds, with more cores, it allows your CPU to do multiple tasks at one time. Higher clock speeds allow for more data to get processed in a given time frame. For example, if you were to upgrade your computer's central processing unit on a desktop computer, any of the programs that you already have on there will typically run much quicker than what they were before, as long as there is no bottleneck from any other component within your computer. Bottlenecking is essentially where one component gets slowed down by another component, and essentially making the money that you spent on that new component almost worthless until you're able to upgrade whatever else is causing slowdowns within your computer. So if you went out and spent $500 on a brand new processor and you still have a hard drive that is super slow, then you're going to be bottlenecked by that hard drive. Or if your computer doesn't have enough RAM, you can be bottlenecked by that. The processor needs RAM space in order to put certain things in there. If there's not enough RAM to hold the instructions and the information needed, then it's not going to be able to load as quick, because it's going to have to go and take all the information from your storage device instead of just taking it from your RAM. To summarize the whole video of everything and give you a quick rundown in more basic terms, the computer's brain is the central processing unit, otherwise known as your CPU or just your processor. For most laptops and desktops, this typically is made by either Intel or AMD. If we're talking about tablets and phones, Typically your processor is going to be made by Samsung if you have a Samsung device. If it's a cell phone, that's typically going to be an international cell phone that has a Samsung chip in it. Otherwise they use Qualcomm Snapdragon chips. For Apple products, Apple makes their own chipsets for their iPads and their phones. You have other manufacturers like MediaTek and Huawei that make processors for their phones. Most of their phones are in other countries, but they are some of the major manufacturers of CPUs. Basic gist of what your CPU does is it fetches instructions, decodes the instructions, executes the instructions, and then stores the information of what happened during that execution. Your CPU is made up of two parts. You have your control unit, or the CU. You have your arithmetic logic unit, or your ALU. The CU reads instructions and then tells the ALU what to do to execute each task. The speed at which these tasks are executed is based on your clock speed, and the amount of tasks that you can do at one time is based on the amount of cores that your computer has. Your clock speed in today's processors is measured by gigahertz. This is 1 billion hertz per second. The higher the number before the GHz when you're purchasing something, the faster your clock speed is. The number of cores that your CPU has determines the amount of tasks that can be handled at one point in time. This would be similar to how an assembly line works. If you have one person working an assembly line building a car, your car is going to be built a lot slower than if you had 16 people working on that same car. Because then you can dedicate each person to a specific task, and then those tasks will get done based on how fast they're able to work. And then if your computer says that it has 8 cores and 16 threads, this is called simultaneous multi-threading, or SMT. And Intel calls this HyperThreading. This essentially means that you create 2 virtual cores per core that your computer has, which then makes it be able to perform 2 tasks at the same time instead of just the one. So if you have 1 core, you're able to perform 2 tasks. If you have 2 cores, you're able to perform 4 tasks, so on and so forth, which is pretty much essentially doubling its performance. The more cores and the more threads you have, the more things your computer can handle at one time. So let's say you're a gamer and you want to stream. The game itself typically takes 2 to 4 cores. Some games even require 6 cores and 8 cores nowadays. Then if you want to stream while you're gaming, then you also need cores in order to process the game and then upload it up to whatever streaming service that you're using, such as Twitch or YouTube Gamers. And while being able to perform multiple tasks at once is benefited by having more cores, the game itself will typically run more smoothly if you have a higher frequency on your CPU. So if you're a gamer, typically more cores and a higher clock speed is going to benefit you a lot more. And that's pretty much the same across any field that requires really doing something with your computer, such as creating videos, photography, gaming, 3D animations. Any content creators typically require higher clock speeds and more cores. That pretty much wraps it up on what your CPU is. I hope you guys were able to learn something and take something away. I hope this enables you to shop smarter, shop better, kind of figure out what you might need. Once I get through all the different components of the computer, I'm going to do a how to shop for these computers, or how to shop for a computer that fits your needs. Hopefully that will be able to benefit you. That should happen in the next month or 2. So that should be plenty of time to go through the summer and decide what you want to buy, if you're buying something for school or if you're buying something for somebody who's going to be going to school. Hopefully that video will be able to help you out and decide what's going to be best for you or for them.
You may have noticed that my setup has changed from the last episode. I built myself a desk about a week ago. I used 4x4s for the legs and the outline of the desktop. The main desktop is a birch composite board, and the desk measures 35 inches deep and 8 feet wide. I used a dark walnut Danish oil for the finish. I put a total of 3 coats on the main desktop and 1 on the cedar 4x4s. It looks better than my old setup there. Let me know what you guys think about it in the comments below.
Other than that, I appreciate you stopping by. If you guys have any questions, please leave anything in the comments below, and I'll see you in the next one.